This is a 13-1, which is just basic trig. I mean, it's mostly Sohcahtoa. So here's a question that you would have experienced in geometry. The wording may not be the same, but the gist of it's the same. A 500-foot cell tower has guy wires attached 15 feet from the top. So we have some tower, and 15 feet from the top there is a guy wire. The guy wire is what holds the tower in position. And of course there's more than one set of guy wires, okay? There's lots of guy wires. But anyways, we're just going to focus on one of them. And those guy wires are 15 feet from the top. Now, it's 500 foot tall, which means there's 495 feet, sorry, not 495, can't math this morning, 485 feet from the base of the tower to that guy wire, okay? And this would be the ground. Let's see here. The guy wires measure 800 feet. Find the distance from the guy wire's anchor, that would be here, that's the anchor where it's in the ground, to the base of the tower. So I need to know this distance right here along the ground. I'll just call it X. Why not? The angle between the tower and the guy wires, that would be this angle. So I'm going to put theta there. And finally, the angle that lies between the ground and the guy wires. I'll call that alpha. Okay, so lots of little things to find. The easiest thing to find is this X. It really is. I mean, we can do a little Pythagorean theorem to get that. We can do some a squared plus b squared equals c squared, the oldest theorem we have. So x squared plus 485 squared is 800 squared. Now, I have no idea. I don't think this thing was designed to be any special triple or anything. I think it's just a problem. But what we're going to do is we're going to subtract 485 squared from 800 squared. And we're going to see what that is. So 800 squared minus 485 squared is 404,775. And the opposite of a square is a square root. So there's X. X is about 636.22 foot. All right, now the next thing is angles. We're going to do trig for the angles, okay? This is the hypotenuse of my triangle. And if I'm looking at theta, this is the adjacent side. So I'm thinking about good old Sohcahtoa. All right. And I've got and I don't want to use this number, it's rounded, okay? So I'm not even worried about it. But I have the adjacent, I have the hypotenuse. That's the cosine ratio. I know that the cosine of theta is going to be 485 over 800. Now, I also know that every single one of you took geometry before you came into Algebra 2. So this is supposed to be something that you know. If I want theta, theta is an argument of cosine. I have to do its inverse, and the inverse of cosine is going to be what we call inverse cosine, and you will hear me say arc cosine. Arc cosine. So what I'm going to do on paper is I'm going to take the arc cosine of both sides. You may not have been shown, or at least you may not remember, this is technically what you do on paper, is you arc cosine both sides. And what that causes to happen on the left-hand side is that theta gets freed up. So theta is the arc cosine of 485 over 800. All right, now we're going to do problems like these in degrees. So my calculator's in degree. Second cosine 485, second cosine brings up arc over 800. And theta is about 52.68 degrees. I think I said 6.8. Yeah, 6.8 degrees. Now, unless you've been living under a rock your entire life, you know that all three angles inside of a triangle have to add up to 180. So my angle alpha, the Jesus fish, plus 52.68 degrees, plus the given 90 must equal 180 degrees. And then we're just going to do some subtraction here. 180 minus 90 is 90. 90 minus 52.68 ought to be 37.32 degrees. So the Jesus fish is 37.32 degrees. And that's everything the question asked for. And yes, this is a geometry type question. That is stuff you should have been doing in geometry. Just because you don't remember it don't mean it ain't true. All right, so this is 13.1. It's the refresher of the basic trig ratio, sine, cosine, tangent, and her reciprocals. The acronym here is Sohcahtoa, or at least the mnemonic device is Sohcahtoa. And the sine ratio is going to be opposite over hypotenuse. And I've got a big or here, and that's because it's also the reciprocal of cosecant. Okay, talking about reciprocals here. Now, if I look at my triangle and I'm doing opposite over hypotenuse, this would be opposite of theta. B, the hard side for kids, is the adjacent side, touches but not the hypotenuse, and C is the hypotenuse because it is opposite of the right angle. So sine would be A over C on this triangle. Cosine, according to Sohcahtoa, is adjacent side over the hypotenuse, or it's 1 over secant of theta, because they are reciprocals. Now in this triangle, that's going to be B over C. Tangent is opposite over adjacent. So if I'm at theta, opposite is an A, adjacent is a B, A over B. And tangent is the reciprocal of cotangent. These are called the reciprocal identities that I'm talking about on the right-hand side. Cosecant, which is abbreviated CSC, cosecant's the whole, remember that? It's the reciprocal of this one. It's the whole. And if sine is A over C, it's going to be C over A. Now cosecant is the reciprocal of sine, so we often write it like that too. Secant is abbreviated SEC, and it's the funny guy. It's the reciprocal of cosine. And if cosine is B over C, this one is C over B. Cotangent is the reciprocal, by the way, it's 1 over cosine. And cotangent is going to be 1 over tangent. Tangent says AO, so it's adjacent over opposite B over A. All right, slide 3. Right triangle ABC with right angle C has a hypotenuse AB equals 5 root 2, leg AC equals 5. Draw the triangle, find the missing side length, and leave as a radical. Find all 6 trig ratios for angle A, and always rationalize the denominator. So if you're not drawing, are you even trying, bruh? This is triangle ABC. C is the right angle. The hypotenuse is 5 root 2, and the leg AC is 5. Now, you are expected to have memorized this pattern, which means that the legs, notice the 5 roots of 2 and the 5? This is 5. And if you don't believe me and you go off the side and you do 5 squared plus A squared is 5 roots of 2 squared, you'll get 25 plus A squared equals 25 times 250. You'll subtract 25, A squared is 25, and by God, A is still 5. Memorize your patterns. So if missing side length is found, find all 6 trig ratios for angle A, and by the way, congruent sides implies a pair of congruent angles. It's a 45, 45, 90. And they want all 6 trig ratios. So we want the sine of angle A, we want the cosine of angle A, we want the tangent of angle A, and then we want her reciprocals, which is cosecant, secant, and then finally cotangent. And yes, the angle is important. Don't just write SIN. Sine of what? Sine of angle A. All right, so if we're at angle A, that's our focus of attention, okay? This 5's relationship is opposite. This 5 at the bottom is adjacent, and this has to be the hypotenuse. All right, time to do some trig. The sine ratio is opposite over hypotenuse, so it's going to be 5 over 5 root 2, which is 1 over root 2. Fugly number. Multiply numerator and denominator by root 2 over 2, and you get root 2 over 2, because that is what the sine ratio of a 45-degree angle is and always will be. It's root 2 over 2. Cosine is adjacent over hypotenuse, which is a 5 over a 5 root 2. Now, that's the same as it was before, so it's going to clean up to be the same, root 2 over 2. Tangent is opposite over adjacent, which is 5 over 5, which is 1. Cosecant, if you do the old Hoe technique, is going to be 5 root 2 over 5, which is just a root of 2 when you simplify your fractions. Secant's going to be the same thing. It's the Ha, but it's going to be 5 root 2 over 5, which is just root 2. And cotangent is adjacent over opposite. It's the AO, and 5 over 5 is still 1. Fun stuff, huh? All right, if theta is an acute angle of a right triangle and the cosine of theta is 4/6, what is the tangent of theta? And good test takers are drawers. Always draw theta in the lower left-hand corner, because the idea here is that these things are superimposed on the xy axis. There's a reason that things get drawn the way they get drawn, all right? The cosine ratio from Sohcahtoa is adjacent over hypotenuse. So next to this theta is a 4, hypotenuse is a 6. She is a right triangle. This is right triangle trigonometry. Now we're going to do a little Pythagorean theorem. 4 squared plus whatever this guy is, we'll just call it A. A squared is 6 squared, 4 squared is 16, 16 plus A squared is 36, 36 minus 16 is 20. A is the root of 20. That would be the root of 4 times the root of 5, which is 2 roots of 5. Now, the reason I had to do that is because they wanted the tangent ratio. And tangent, last I checked, was opposite over adjacent. So opposite of theta is now a 2 root of 5, and adjacent to theta is a 4. And 2 over 4 cleans up to be 1 over 2, root 5 over 2. You have to simplify your fractions. You are here to learn math. Given the cotangent of beta, that's the Greek letter beta, is x, what is the sine of beta? Now, every number in existence exists over a 1. Same orientation of the triangle, Greek letter beta right here. The cotangent ratio is AO, so adjacent is an x, hypotenuse is a 1. The oldest theorem known to man, at least that we know of, is a squared plus b squared equals c squared. So x squared plus this guy, which I'll just call a, plus a squared is 1 squared. A squared is going to be 1 minus x squared. And a is going to be the root of 1 minus x squared. And there's nothing you can do with that. You cannot say that's 1 minus x, because it's not. So a is the root of 1 minus x squared. Now I wanted the sine of beta. Sine of beta, last I checked, was opposite over hypotenuse. Opposite is going to be the root of 1 minus x squared. The hypotenuse is 1. So it just reduces down to root of 1 minus x squared. Easy peasy lemon squeezy. Find a side length with technology. Okay, so A is going to be opposite of the given angle. C is the hypotenuse. And 15 is adjacent. It touches the angle, but is not the hypotenuse. And you can use any trig ratio you want. I'm just going to start with side angle A, with this side here, side A. When I look at it, I see opposite and I see this guy. See, I have a 15 here. I know that the tangent of 28 degrees must equal A over a 15. I know that the opposite of division is multiplication, so 15 tangents of 28 is side A. Now again, you check your calculator, make sure it's in degree mode. 15 tangents of 28 degrees is 7.98. Now some people like to switch over to Pythagorean theorem here. The problem is 7.98 is rounded. Let's look at this one. If we're looking for angle C, or side C, we have adjacent and hypotenuse. That's the cosine ratio. The cosine of 28 degrees must be 15 over C, and this one's a little harder to do. So what we're going to do is we're going to see both sides, because we can't solve for a variable if it's in the denominator. So I see both sides. C times the cosine of 28 is that. C times the cosine of 28 is 15. And now to do the isolation, I divide by the cosine of 28. A lot of y'all don't like to write. That's why you have zero retention. It's an issue. You have zero retention because you don't like to write. I can tell you exactly who you are. It's about 16.99. All right, moving forward because the bell's about to ring. I got class in 5 minutes. You are looking down from the top of the building at your car. As you walked in, you counted the steps and estimated you parked 500 feet away from the building. So you parked your car 500 feet from the building. If you are looking down at the car at an angle of 25 degrees, how tall is the building? Now, here's the thing. The angle that you look down at is formed with the horizon. It's not formed inside the triangle. That would be an angle formed with the building. You were looking down with an angle formed with the horizon 25 degrees. Now, here's the cool thing about this stuff. We have a horizon that is parallel to the ground. By alternate interior angles, those two things are the same. That is an angle of depression, and angles of depression are congruent to angles of elevation. Angles of depression are congruent to angles of elevation. It's from geometry, kids. How tall is a building? Let's call it X. X is going to be opposite of this 25 degree, 500 angles is going to be adjacent. That is the tangent ratio. The tangent of 25 degrees must equal x over 500. And that's a simple 500 both sides problem. 500 tangents of 25 is my x. Switch over to my calculator, 500 tangents of 25. And I get it's about 233.15 feet. Including however tall you are. And hey, that's it. So there you go. There's 13-1 for those of you who are absent.